Hello everyone. In this video we're going to be solving a nice exponential equation, a very nice exponential one actually. We have x to the power x squared equals x to the power 2 to the power x. Now we're going to be solving this equation for all types of solutions like real, and then we're going to look at a graph at the end. And the results might be a little surprising. Anyways, let's get to work. If you've seen some of the other videos that I made that are similar to this, you probably saw this video where x squared equals 2 to the power x. Go ahead and take a look at that video. In that video, actually, something is missing. Anyways, I'm going to try to share the link with you right here so that you can take a look at the video and comment. Anyway, so let's see how those equations are related. So in order to be able to solve this problem, I'm going to go ahead and divide both sides by x to the power 2 to the power x. And obviously, if x is 0, then I'm going to get something not well defined on the left-hand side, which is 0 to the power 0. So x cannot be 0. So I'm allowed to divide by that, both sides, okay? Since x can't be 0, this is not going to be 0 either, right? So let's go ahead and divide x to the power x squared by x to the power 2 to the power x. And then we're going to look at the following. Since we divided both sides by the right-hand side, this becomes 1. Now, we're dividing two powers with the same base, so we can use properties of exponents. And what does that say? If you divide two powers with the same base, you subtract the exponents. That's the rule we're going to use here. So it's going to look like x to the power x squared minus 2 to the power x equals 1. Awesome. It's important to get 1 because we can kind of look at different cases here. If a to the power b is equal to 1, then we'll basically consider 3 different cases for real solutions. First case, a is 1 and we don't really care about b. It can be anything. 2, a is negative 1 and b is even, because a negative 1 to any even power is always positive 1. And the third case scenario is a does not equal 0, but b is equal to 0. Now, why does a have to be different from 0? Because if a is also 0, then you get 0 to the power 0, which is not always 1. It is an indeterminate form that we usually come up or encounter in limits. Anyway, so we get this equation, and let's go ahead and take a look at each case. All right. First case, we have a equals 1, which is the base, right? So the base is going to be 1, and we don't care about the top. First case, x equals 1. That's definitely going to work because when x equals 1, any power of 1 is going to be 1, so that's a valid solution. Second case, x is equal to negative 1, and x squared minus 2 to the x is even. Now, we probably know that this is always going to be even except when x is equal to 0. So if x is not 0, and we already talked about it, x cannot be 0. So this is always going to be even, which means x squared must be even, which means x must be even. But negative 1 is not even, so this is not going to work. So the second case is actually discarded, and we're going to look at third case, which is when a does not equal 0. We already talked about it. X can't be 0, and the exponent must be 0. This is what brings us to that problem that I made a while ago, a long time ago, on x squared equals 2 to the power x. Hopefully, you can check that out. Okay. So from here, what are we getting? Let's take a look. When x squared is equal to 2 to the x, you can kind of look at it this way. If x is 2, then we're going to get 2 to the power 2 equals 2 to the power 2. But that's not the only solution. By the way, x must be positive here because we're kind of looking at two exponential functions that are raised to variable powers. So if x is negative, we're going to run into issues. We can talk about that later. But here, this equation normally has 3 solutions. But we can only take the positive ones. So here's what we can do. We can log both sides. Let's go ahead and do it. ln x squared equals ln 2 to the power x. And then bring the 2 to the front. 2 ln x equals x ln 2, and then put the x's together like ln x over x equals ln 2 over 2. So this automatically tells you that x equals 2 is a solution. But that does not necessarily say that is the only solution. So you kind of have to look at the graph of ln x over x, and if you do, you're going to realize that it actually intersects this horizontal line at more than one point. And how do you find the other solutions? By doing a little bit of manipulation. This doesn't work with all numbers, but 2 is, in this case, is very special, and I'll tell you in a little bit why. But you can basically double the numerator and the denominator, and then use this 2 as a power and write it as ln 2 squared, which is ln 4 over 4. So in other words, ln 2 over 2 equals ln 4 over 4, but you can't say the same thing for ln 3 over 3 because that does not equal ln 9 over 9, does it? Okay, so that's a very special situation. So from here, we also get x equals 4. Interesting, right? So far, let's see what we got. We got x equals 1, x equals 2, and x equals 4. Are those the only solutions that we're getting? Okay, now what happens with the original problem? Let's kind of take a look at it real quick. If you have x squared equals 2 to the x, then you can kind of also use a function called Lambert's W function, right, for this problem. But you kind of need to, manipulate this a little bit. And Lambert's W function works like this, and I'm going to leave the rest to you as an exercise. But whenever you have something like, y times e to the power y, you can basically w it, and it's going to turn into y. So it's basically extracts this y in the expression y times e to the y. In other words, it's actually the inverse function of y e to the y. Make sense? Okay. And of course, this also works with something like x times ln x, because what happens with that is you can basically write this as x as e to the power ln x times ln x, and when you replace ln x with t, you get t times e to the power t. Again, you can do w or Lambert's W function to solve this problem. Okay, anyways, so that gives you normally 3 solutions, one of which is negative. But in our case, would a negative solution work? And I would say it doesn't. The problem with that is we're going to have, and you can test it out. You can definitely check it out, but it's just not going to work. So we got 3 solutions. Looks like the solution set is made up of 1, 2, and 4. By the way, I find this problem pretty interesting because the solutions are all powers of 2. I don't know if that's because of 2 to the power x, but I was wondering, can you come up with an equation, an exponential equation, whose solutions are 1 and 2, or whose solutions are 1, 2, 4, and 8? Just adding another power of 2 every time. Anyways, let's go ahead and take a look at the graph, and we'll finish up with that. As you can see, the graph of y equals x to the power x squared is going to be very similar to x to the x, which kind of looks like this, but it's just curved a little differently, and obviously it's going to have an inflection point, I think, somewhere between 0 and 1. But the graph of x to the power 2 to the x is obviously something that kind of seems to be growing faster first, but then the other one, I think eventually x to the power 2 to the x is going to beat the other one. But guess what? They're going to intersect at 2 more points at x equals 2 and x equals 4. Because what happens is when you replace x with 2, you're going to get 2 to the 4 from here. And here, you're also going to get x equals 2 to the 4. When you replace x with 4, you're going to get 4 to the power 16. And here, you're also going to get 4 to the power 16. So something nice about this equation is that 2 works as well as 4, because 4 squared is 2 to the 4th power. And 2 and 4 are the only integers that gives us this interesting relationship. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.